If I get access to a single Kubernetes pod, can I take over an entire cluster? Sometimes yes. Hello everyone, this is me, Hack, and in this YouTube series, I will show you exactly how that happens and how to stop it. This is a short series on attacking and defending Kubernetes. We will start with just enough Kubernetes to understand what's happening. Then in later videos, we will talk about different kinds of attacks and different defenses which we can implement to protect against those attacks. Everything which you will see in this video is based on real incidents, red team techniques, and sets of extremely common misconfiguration which happens in a real production environment. Let's clear one thing up. Kubernetes is not Docker. Kubernetes is a control system. Think of it as a brain that makes decision, controlling machines, running containers for you automatically, and everything and absolutely everything goes through a central API. Before we attack Kubernetes, you need to know which part actually matters. Not all components are equally important or equally interesting. Some are boring and some are not needed for our POV, from an attacker's POV or from defender's POV. So we will start with something called kube-apiserver. We can also call it the front door. Why? Because this is the most important component in Kubernetes. So whenever you run a command like kubectl or kubectl get pods, you are not talking to a node, you are talking to an API server. Every single action goes through it, like creating pods, reading secrets, executing commands, and modifying an RBAC. If you don't know what node is or kubectl or pod, we will discuss later in this video. Behind the API server is etcd. etcd is basically key value database. It stores service account tokens, cluster state, and secrets. Basically, everything in Kubernetes is stored in this particular database. If an attacker is able to read etcd, this basically means that they literally own the entire cluster and they can do whatever they want. And yes, people do expose etcd, and we will also talk about how we can break this, and then we will also talk about how we can fix it. Scheduler. Not sexy, but still relevant. The scheduler decides which node a pod runs on. Most of the time, you can simply ignore it, but in advanced attacks, influencing scheduling can mean that you can force a pod to run on a weaker node and target nodes with very sensitive workload. Now let's move on to nodes. So what is node? A node is a simple machine, either physical or virtual machine, that runs your application inside a Kubernetes cluster. So think of cluster as a whole system, and a node as a worker which actually gets the job done. Every pod you deploy, every container you run lives on a node. And here's an important security detail. If an attacker compromises a pod, they are already inside a node, and once you are inside a node, your chances of owning the entire cluster becomes exponentially very high. Every node runs a component called kubelet. The kubelet basically starts a container, stops it, and talks to an API server. If kubelet is exposed or misconfigured, attackers can execute commands in a pod and sometimes escalate to the node itself. Under the hood, Kubernetes uses a container runtime like containerd. A container runtime is a software on each node that actually starts and manages container. Kubernetes itself does not run a container. It will go and tell the runtime what to run, and the runtime will do the low level work. And here's something important. Containers are not virtual machines. Virtual machines basically emulate an entire operating system. On the other hand, containers share the host's kernel, and they are isolated process which are lighter, faster, but closer to the host. The difference in terms of security is huge, because if isolation fails, you are the host. So in terms of like Kubernetes, if you're running a pod which is privileged, which we will talk about this later in our next video, if you're running a pod which is privileged or has a mount, or a special or a dangerous Linux capabilities, you can be root on that node. Next, we will talk about pod. So what is pod? So pod is our smallest unit Kubernetes run. It is not a container, It's a wrapper around two or more containers. Containers inside the same pod share three important things. First one is network. They share the same IP address and ports. Second is volume. They share the same volume, the storage. And the second is identity. They share same service account and security context. This means that containers inside a pod trust each other. Now here's something important and kind of cool. Pods don't usually talk to an IP address directly. They talk to us services. Services provide stable networking, they give you consistent DNS names, and they handle internal load balancing between multiple pods. So even if pod is like destroyed or rescheduled or recreated, the services stay the same so they can talk back later. And from attacker's perspective, if you can control a pod, you may be able to abuse its identity to talk to other services inside the cluster. Kubernetes does not care whether you are a root on a node or not. It cares who you are to an API server. In Kubernetes, identity is everything. Identity can be a user, service account, or a token mounted inside a pod. Most pods automatically receive credentials. That means by default, workloads can talk to an API server. And this is where things gets interesting. Many real world Kubernetes attacks are surprisingly simple. Steal a token, ask the API server what permissions they have, and there's a very famous command which is kubectl can I kubectl odd can I list. We will talk about this later, but yeah, basically ask the API server what we're allowed to do, abuse those permissions, no exploit required whatsoever, or no zero day, it's just identity. And this is exactly like what we will cover in our upcoming videos, like how we can use this and abuse the tokens and move further in the Kubernetes environment.